This is problem number 4 from section 3.2. In this problem, they want us to solve the following equation by completing the square. So because they want us to use completing the square, we can ignore the other 3 ways to solve quadratics. We're just going to specifically look at completing the square. Now, this problem is a little bit more difficult because if you want to complete the square with a leading coefficient, usually what I like to do is, if you notice that the leading coefficient is -2, I like to factor out the -2 to complete the square. So here's how we're going to start this problem. I'm going to move the -1, the c part, because I don't really need it. I'm going to move it to the right side. So I'm going to end up with -2z squared plus 5z equals 1. I'm going to move it away, that way we don't have to deal with it. The second thing, because of the leading coefficient of -2, I'm going to factor out -2. So I'm going to take a -2 out of these two terms. Now that's going to end up giving us a fraction, but that's okay. It's pretty easy to deal with the fraction as long as we don't have a leading coefficient. So let's factor out the -2 out of each term. That'll be -2, parentheses, z squared is all that's left in there. And then when you factor a -2 out of this, right, you're essentially dividing it by -2. So this is actually going to be -5/2z equals 1. And you can see that obviously if you multiply by -2 to this fraction, the -2's would cancel and you're left with 5z. So it, when you're factoring a number out of something that's not divisible, right, you essentially just put it as the denominator because you're dividing it out. Okay, now we're ready to start to complete the square. We're going to use -b over 2a. So -b over 2a squared equals, we're going to use b, which is obviously -5/2, and the a part is 1. So we end up with -5/2 over 2 times 1, and we're going to square this. This will end up with 5/2 over 2 squared, which this will give you 5 over 4, right? 5 divided by 2 divided by 2 is 5 over 4. So 5 over 4 squared, which ends up being 25 over 16 when you square the top. 5 times 5, when you square the bottom, 4 times 4, 25 over 16. So I'm going to add in 25 over 16 on each side. That's what it says, add that number to both sides. But I'm adding 25 over 16 inside these parentheses, so we got to do something just a little different with that. So -2, we have z squared minus 5/2 and actually I just noticed this is what I'm going to do that's going to be even a little different here before I add that to both sides. This will make the problem a lot easier if I just divide the -2 to this side. I think that'll make the problem so much easier. So at this point, when you factor out the -2, it makes sense. Let's just divide it over to this side. So we're going to divide each side by -2, and that'll get rid of the parentheses and actually make the problem easier. So let's go ahead and do that. Z squared minus 5/2 z now equals -1/2. Now I just add the 25 over 16. I don't have to worry about the parentheses. So let's add the 25 over 16 to each side. So we have z squared minus 5/2 z plus 25 over 16 equals -1/2 plus 25 over 16. Now I want you to keep in mind, this is a little bit of algebra that we did here by moving the 1 over, factoring out the 2, and then dividing by it. That had nothing to do really with the completing the square. Right? Those were just normal algebra moves. The completing the square part was adding the 25 over 16 on each side. And that doesn't change anything because we're doing it to each side. Now we want to factor this out. Well, what's the factors of 25 over 16? Well, the factors of 25 over 16 was 5 over 4 because we did 5 over 4 squared to get it. So 5 over 4 is the number that we're going to use that's the perfect square, that when you add two 5 over 4s together, you end up with 5 halves. And we can prove that real quick. Up here, I'm going to write, if we have 5 over 4 plus 5 over 4, you get 10 over 4, which reduces to 5 halves. So we know when we add 5 over 4 to itself, we're going to get 5 halves. We need negative 5 halves in the middle, so it's really just going to be negative 5 over 4 and negative 5 over 4, which will give you negative 5 halves. So right here, we're going to, let's factor this out. Let's slide over just a little bit. We're going to factor this out, and we're going to say that this would be z, and this is minus 5 over 4, minus 5 over 4. So this factors down to this. And it equals, let's go ahead and add these together. So if we take 25 over 16, you can use your calculator to do this. So negative 0.5 plus 25 over 16. If you get it in fraction form, it gives you 17 over 16. So that looks a lot simpler now. This can be combined together, the same term, right? Multiplying two of the same factors. So that's z minus 5 over 4 squared equals 17 over 16. And now we can actually use the square root method, right? Method 4 there, to solve this. So let's square root each side. When we square root each side, we get root z minus 5 over 4 squared equals plus and minus, remember, root 17 over 16. This gives you z minus 5 over 4 equals plus and minus root 17 over 16. Now we can go ahead and add this over. So that's z equals 5 over 4 plus and minus root 17. Now I'm going to split this root between the top and the bottom. Right? The top will be root 17. The bottom, if you did root 16, that's 4. And so this is our solution. I'd like you to write those out. So say z equals 5 over 4 plus root 17 over 4. Now you could add those together because they have the same denominator if you wanted. Or 5 over 4 minus root 17 over 4. And those are the two solutions to this problem.